Assalamualaikum warahmatullahi wabarakatuh. Today, we from Group 6, we present about the group assignment Multivariable Calculus BEE 20303. Here's our group members. We have Muhammad AZLY bin AZAHARI, Muhammad HILMAN HAKIMI bin YUNUS, Muhammad SYAQIR bin AHMAD SAFARUDIN, Muhammad Amiruddin bin HASROLNIZAM, which is myself, and Muhammad ALIMIN bin MOHD PAUZI. So, for this assignment, we have 4 questions. So, we have divided the task between us. For the first question, will be presented by Muhammad HILMAN HAKIMI bin YUNUS. The second question will be presented by Muhammad SYAQIR bin AHMAD SAFARUDIN. The third question will be presented by Muhammad AZLY bin AZAHARI. And the fourth question will be presented by Muhammad ALIMIN bin Muhammad PAUZI.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hilman bin Yunus, and now I'm going to show you how to do the summation for question 1. Okay, first, let's start with question A1, which is multiply the integral of this. Okay, in this summation, I will be using MATLAB 0, y, we get 9 to the power of 3 over 2. Then let's do the dy. Okay, we get the z to the power of 2 minus 4 to the power of 2 over 8. Then we find the integral in terms of dz, which is the limit is 0 and 1. And 1. Okay, we get the answer here. Okay, now for question 1A2, you can see here is the function and the origin is here. Okay, after we put all the upper limit, lower limit, you can see here is the function for the double integral. So now let's start with the function. Okay, we get 40 over 3 minus 2y to the power of 2. Okay, now let's do the integral of dx. We get 76 over 3. And as you can see from the calculation, also we get the 76 over 3, also 25.333 units squared. Okay, now let's move to question B, which is evaluate the following triple integral by using spherical coordinate. Okay, now let's define the lower limit and upper limit for dz, dy, and dx. Okay, now let's find the triple integral for this question. Okay, now you can see the answer is 6.3691, and you get the 6396.1 unit cubic. Okay, now let's do the question 1C1, which is by using polar coordinate, evaluate the function if origin is in between circle and in the first octant. We need to find the equation first. The function, which is here, is you can see the double integral of x squared plus 9 squared r dr d theta. Okay, we get 15 over 4. Okay, now let's do the integral for theta. Okay, we can see here we get 15 pi over 8. Also 5.89 units squared. Okay, now for the last question is C2, which is by using double integral, find the area of the region enclosed by y sin x and y cos x equal pi over 4 and x equal pi over 2. Okay, for this equation, somehow I cannot run the summation, but we need to do the by hand first, and until the second integral, and from the second integral we can do the summation. Okay, now let's do the summation. First, we need to define the function, and now we get the answer, which is 0.4142. Also same here, unit squared. Okay, that's all.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad SYAQIR bin SAFARUDIN. My number matrix is DE20107. Okay, I will present for question 2. The mathematical software that I use to solve this question is Maple. Okay, first for the question A, this question we need to find the first partial derivative. So here we need to differentiate the equation against to x, y, and z. So we can see that we got the same answer for calculation and simulation. Okay, next for question A2. Okay, for this question, we also need to differentiate the question against to x, y, and z. But for this question, we use the product rule because have a two function for this question. So we can see that we got the same answer for calculation and simulation. Okay, next for question 2b. Okay, this question we need to apply the chain rule. Okay, first we need to write down the equation, and then we need to differentiate the function z against to x and y, and then we need to differentiate the function x and y against to u and v, and then we can get the answer here. So we can see that we got the same answer for calculation and simulation. Okay, next for question 2c. Okay, this question we need to show that the function is satisfy the Laplace equation is equal to 0. Okay, this is the second order partial derivative. Okay, first we need to differentiate the function against to x and y. So here we need to use the product rule. And then we do the second differentiate also against to x and y. And then we can prove that the answer is equal to 0. So we can see that we got the same answer for calculation and simulation. Okay, question 2b. We need to find the delta z over delta x. So this is about topic implicit partial differentiation. Okay, first we need to differentiate the function here against to x and z. And then we use the formula negative fx over fz, and we got the same answer here for calculation and simulation. Okay, for the last question, D2. Okay, first we need to differentiate the equation also against to x and z, and then the formula negative fx over fz to get the answer. And then we can see that we get the same answer for simulation and calculation. So that's all.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad bin AZHARI. My number matric is DE200067. I'm from group 6 and section 3. So now I'll proceed for question 3. So first of all, for the question A, we need to calculate the divergence of the curl vector. So the first step, we need to do the cross product. And after we do the cross product, we need to differentiate the answer against the x and y. So after the calculation, we get the divergence of curl is 0. So this means we achieve the same answer for the simulation.
So for the simulation question 3a, we need to declare the simulation variable, which is x, y, and z. And after that, we declare the function that we will use, which is the given in the question, which is the exponent power of 2z plus y, sin y z power of 2, and cos y z x. And the variant is y z x. After that, we will insert the formula to find the curl of the divergence. And after we insert all the formula, we run the project and we will get the answer is 2. Answer is 0.
Next is question B. So in this question, we need to find out whether the equation is conservative or non-conservative. So next, we do the cross product. After that, we need to find the word done. In the word done, we need to identify the final and the initial value. So the final answer is negative pi over 3, same as the simulation. And it is conservative force.
Okay, so for the question 3b, we need to calculate the work done and we need to observe whether the force is a conservative or not a conservative. So for the work done, we need to insert and declare all the functions. So for the fit force, we use the 3x power of 2 and we use the integer f0 and negative y, and for the point b, we use the integer g0 and 0. And for the answer, we will add the a and b answer to get the work done. So after we insert the function, we run the process, and we get the answer for the work done is negative pi power of 3. So after we get the work done, we need to observe whether the force is conservative or not. So we delete all this function and we replace it with the declare function of if answer is equal to 0, the force is conservative force, and if the answer is not 0, the force is not the conservative force. So we run the process and we will get the answer is 0 and the force is the conservative force.
So next is for question C. Question C, we need to evaluate the equation. So firstly, we need to differentiate the function z against x and y. And then for the polar coordinates, we need to integrate it and we will get the answer, which is 2805 by 2 over 8 pi. Thank you. So it's same as the simulation, which we get by using mathematics. So thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is ALIMIN and I will proceed to the question for B2, which is sketch the graph of the surface. So for the first equation, for the x square plus y square equal to 4 is the refer to the cylinder. And second, z equal to square root x square plus y square is refer to the cone. And z equal 4 is plane and z equal 0. This is z over 0. So this answer same with my manual sketch like this. So for the second, for B2, we just find the division of fxyz from the equation. So we need to differentiate it, and we get d over dxy plus x d over dyy plus d over dzz is equal to x plus 1. So for the third question, B3, we need to use Gauss theorem to find the flux of the vector field fxyz across the surface. So for the flux 1 is referred to yi plus syj plus zk multiply k d theta dr. So we replace this equation to the z1, and z1 is equal to 4. So integrate z1 d theta dr, and we get answer is 16 pi. So for the second flux, negative z2 d theta dr. Because negative is we used to negative k. So negative z2 d theta dr. So we integrate it, we get the 0. And we calculate the total flux of the vector field. And we get the answer is 16 pi. And this answer same with my manual calculation. 16 pi. So for the for C1, sketch the surface of the plane. So this equation is x plus y plus z equals to 1. And this is the simulation of the sketch, like the manual. So for the question for B2, we need to evaluate this equation using the Stokes theorem. So for this question, we need to find the value of Rs and Ry. Rs is 1, 0, and negative 1. And Ry is 0, 1, and negative 1. So we make it in the metric form. And this is from the question, which is negative 3 over 2 y square I minus 2xy j plus yzk. And we make it the metric form, and value for I we get zi, j is 0, and k is 3y minus 2y k. So we total it, and we get zi plus ky. So for the second metric form, we use the number that we get from the differentiate this, and after that we get the value I is I, and j is negative j, and k is k. So we sum it and get the answer is I plus j plus k. So after that, the value of metric this and metric this, we multiply it. So zi plus yk multiply I plus j plus k. So for the multiply it, value for I we get zi, j is 0, and k is yk. So after that, we differentiate it, z plus y, we integrate it, z plus y dy dx. So we replace z plus y into the 1 minus x. So after that, we integrate it, we get the answer is 1 over 3. That's all from me. So for the lastly, for this answer is same with my manual calculation that I get lastly 1 over 3. That's all from me. Thank you.